Assalamu alaikum. Today we are going to talk about our final year project, which is sea level anomaly and earthquake prediction in endangered countries prognostication. So, what our paper does is we try to find out the countries that are going to face risk due to earthquake or sea level anomaly. So, why did we select two different type of natural disaster? Because earthquake is more sudden and sea level anomaly is more slow but inevitable natural disaster. So what we try to look for is that we wanna find the endangered countries, the countries that is going to be under the sea level or that is going to be face earthquake. So we try to predict those countries, and then we try to come up with an early warning system that this is going to be happening in your area. So also our aim of this paper is to observe how deep learning technique performs in the case of earthquake or in the case of slow and inevitable disaster like sea level anomaly. So our problem statement is existing machine learning technique is not reliable enough to find the endangered countries uh, due to about the upcoming earthquake and sea level anomaly. So our project objective is to implement and evaluate the model for earthquake and sea level anomaly to find the endangered countries as well, and also you have to find the risk facing countries due to earthquake and sea level anomaly. So what are the significances of our project? So our project will help to reduce human death risk and assist to project the endangered areas that this much area is going to be under sea level. Or this much area is going to face the coastal flooding, or about the earthquake that this area can be recently can have an earthquake can occur in this recent area. So also expected to take proper precaution for coastal development. So if a government knows that, or if the people knows that this area is going to be under the sea level, so what they are going to do is they will take proper precaution for the coastal development and also the migration of the human people. So those people who are living in the coastal area right now, so they will move towards inland, and the government can manage better in terms of the resources as well. We tried to come up with deep learning with earth science, which is still relatively a new area. So what is the originality in our project is we try to predict certain period of time for earthquake. So what the previous researcher did is they tried to detect the earthquake from the seismic wave, whether this is just a wave or this is an earthquake or not. Also they tried to project project the aftershock of the earthquake. So after a large earthquake there are several aftershock. So they try to predict whether this is an aftershock or not. So for the sea level anomaly, there are very few research work has been done. So one of them was they tried to predict the sea level anomaly in the Caspian Sea, and another research was done on the Pacific Ocean. But they used the global mean sea level. So what we tried to come up with, we tried to select a certain sea point surrounding a country. So for our scenario, we only selected the Jakarta in Indonesia, and we try to see whether the sea level is going, how much the sea level is going to be risen in that area. So our methodology is we collect our data from our earthquake dataset was collected from United States Geological Survey, and our sea level anomaly dataset was collected from European Space Agency, ECB products, and also we had another dataset to find the risk facing countries regarding sea level anomaly that was collected from the World Bank. So after the collection of the data, we did the data preparation and cleaning, because our sea level anomaly dataset had was in NetCDF format, so we had to modify and we had to convert it into two-dimensional data. So we have to use Python for that, and also we did the data visualization, which can be seen here. That for the earthquake, it can be seen that there are many earthquakes happening around the world, and for the sea level anomaly. So this was the sea level anomaly in 1993, and this was the sea level anomaly in 2015. So it can be quite easily to understand that comparing these two, that in 2015 the sea level is rising more steadily. And then we select our features for our model, and then we convert our data into time series. After that, we build the deep learning model, which is our long short term memory LSTM model. So forecast using the LSTM model, and our forecast it can be found here that for the earthquake we try to predict until a certain amount of time, which is a quarter of the month, quarter of the year. Sorry. So 4 quarter means the fourth quarter of the year. That means from the month October until December. And for the sea level anomaly, it can be seen that this is the red line is the real value and the blue line is the predicted LSTM, our LSTM model has been predicted. So it can be so for the earthquake it didn't perform quite good but didn't perform quite bad as well. But for the sea level anomaly it performed quite good with the RMEC around 0.504. So after we did we save our result in the CSV file and we build a web platform as well, and we try to show the result through the web platform for the user. So this is our web platform. So this is the home page for the user, and if they go below they can forecast. They have to put the country name. For our demonstration it's Indonesia. If they select forecast, so they can see the next earthquake which will happen, the magnitude over 5.5, which will happen to Indonesia is around this month October and November, and the quarter of the year is 4. And also they can see the sea level anomaly in meter for all of the 12 months. So what are our findings are that our model predicts, I have shown you previously, our model predicts until a quarter of the year for earthquake occurrence, and our model predicts sea level anomaly as well for the next 12 months. So this is for the next 12 months. That's all. Thank you very much from our group.